Good evening, everyone. Welcome to the kickoff of the fall program of Anne Arundel Bird Club. My name is Chris Eberly, still president, and will be until we find another one. But I'm glad we have everybody here joining us virtually. We do very much look toward that day when we can get back to in-person meetings. But I think we have a little ways to go. But for now, we'll stick with the virtual format, benefits of which are we get to record the meeting and other people can then see it after the fact. Let me start off with a couple of announcements. There is a Bird Day celebration at Swan Creek Wetlands on October 16th. And Sue and Alan Young will be representing Anne Arundel Bird Club at that event. And I don't know, I suspect if anybody else wants to show up just to lend a hand, that'd be appreciated. And I think there'll be more information forthcoming, although I did see an email and didn't get a chance to read it yet about that, but we'll make sure we get information sent out about that. Well, you know, while we're on that, Sue and Alan, do you want to give an update on our bird walk and field trip activity for the fall? You're muted.
We're here.
Okay, good.
So.
Okay, I'm sorry. Yeah, we're very happy that after a very long period of time, we've been able to get back to starting some. We've got some, some considerations we're trying to do to keep us all safe. So we started up for September. We had 6 trips, as I mentioned a little earlier. And of those 6 trips, we had to cancel 3 of them, 3 of our, really kind of very popular ones. Greg Kern's pontoon boat ride through to see the Sora and, to check the nets and everything. Second was the Band-Aid one with Marion. And then also our Bombay Hook one, which was in August. But we started off with Kinder Farm Park on the 5th. We had 39 species of birds. It was kind of disappointing to me because we didn't have a lot of migrants. In fact, I thought it was kind of, I'm looking for them and I was geared for them, but we didn't have a lot. Let's see, we did have, as I'm trying to talk up a little bit, is about our northern bobwhites. We had a couple of northern bobwhites singing, and I'm fairly certain that it's still the continuing birds from the release more than 1 year ago. I guess we're in our 2nd cycle now. But we had 2 singing, and I've got pictures of the birds. They're very beautiful and they look great, but they're still not considered wild birds. We're still trying to find evidence of any type of mating activity. Even unsuccessful tries would be great to find. So that's one of the things. And then we had our cattle egrets, which were very vacant throughout our time that we used to see them. They were there on that day. The next one was at Cromwell Valley, which we try to do every fall because that's a good place for warblers. We were surprised to also have a black-billed cuckoo to start kind of find on the day. That was really a nice bird. It's not unexpected there each year, but it's still a great bird that close to home. An olive-sided flycatcher, released, and 9 warbler species, which was fun. Most of the ones were expected, the black and white and the common yellow throat, the American redstart and the Parula Maggie. But we also had Blackburnian, a yellow warbler, a chestnut-sided, and a Canada warbler, which was really fun. So we had some good warblers, and we had warbling vireo, almost all the vireos. So it was a nice day at Cromwell Valley. We had 57 species. And then our 3rd for the month, Leo Dilling's going to do for us on Sunday at Quiet Waters. So that'll be our first Quiet Waters. So we'll do a Quiet Waters and a Kinder Farm Park every month, like we have in the past, because they support us and we have our meetings in their locations and so on. So that's that. For October, like I mentioned, we'll have the Quiet Waters in the Kinder Farm Park, but we're also going to do Wooten's Landing, and we have a new leader, Fred Schaefer, good guy. Fred's going to come and take us through Wooten's. Masonville Cove, we're going to do that, which is another kind of a local place, but it's the other side of Swan Creek. It's the area that they've built up with the dredge cell and so on. And that's always really nice most all the time when you go there. And then Greenberry Point, we're going to do near the end of the month, I think. And Linda's going to take us through that. Linda Bishop will take us through that again. And I want to ask Sue to talk about the Swan Creek thing, because that was going to be one of our walks.
Yeah.
Okay.
We were originally signed up to do that. When I talked to Tim, we asked him we actually wanted the end of September for that, or the beginning of October. But we were told we had to wait till October 16th. Now they have that open house. So we effectively got booted out of that. However, Tim is going to be putting out an email, and people need to sign up with Tim. And if you're the first 20 you get in, it's possible they're going to be able to do a second walk from 8 to 10 with Stan Arnold, who was going to lead our group. But even if you don't get in with that, from 10 to 2 is an open house, which means anybody can come and anybody can go birding for those hours. So even though it wouldn't be a lead walk from 10 to 2, hey, Kyle Rambo's coming in. It's still an opportunity to get to Swan Creek, which is absolutely our #1 place to go in Anne Arundel County. And we haven't gotten to go for well over a year. So I'm very, very excited about the opportunity to go. And Peter, you said you were going to bring some materials for us for the table.
Because we'll do an Anne Arundel Bird Club table there.
Yeah, I'll bring the 10 cards.
Great, that'd be really great. And anybody that wants to come and help us, that'll be good, so that folks can get out and do a little bird. Going to open up the wetland. You're going to be able to go and see, not necessarily around the dredge, but you'll be able to go to the wetland, which is very, very nice this time of year. So anybody that can come and give a little time on that day to help us, just contact me and we'll work out a little schedule or something.
But even if you don't want to do the table thing, at least come and go out to the wetland, because they get so many great birds out there. It's so fun to go.
You get Fowler ropes, all kinds of sandpipers. You can get Fowler ropes, you can get avocets, you can get lots of really cool sandpipers, which makes you giggle when you think you're just standing out there on the edge of the city looking out into the harbor. So it's fun. And I want to thank Deb Wade for helping us so much and keeping the communication. We've kind of decided we're going to put out our monthly walks each month. So as there's changes and so on, it'll be the most current that we know about ones that are going to be held. So we'll put out a monthly report to the club about what's available. And the protocol that we've set up is fairly simple. You contact the leader. We're going to try to cap it at 10 people if we can. The social distancing and all the things that we're living with in our life, we're going to try to do a good job with that. I've seen that Dawn was with us tonight, and Alan and Regan, they were with us on the trip to Cromwell Valley, and I think it was a good trip. Maybe given the conditions we were trying to figure out how to do, I felt like they were both, our walks have been successful so far in that regard. So that's all I wanted to share, I guess. Any questions, if anybody has them, you can either ask them now or you can write to us or however.
Well, I certainly appreciate all the efforts you guys continue to put in to this, in spite of far from perfect conditions and circumstances. So thanks again for setting up these walks and leading them and making people have fun.
We haven't filled any of them up yet, so don't be shy about signing up. But so far, so good, I think.
No other questions? And let's see, what else do I have here? Um, so yeah, we have a chimney swift tower installed, and not yet online with a camera that's functioning, but we have that project at Kinder Farm, and kudos to Pete Bungay for picking up this thing from an idea and shepherding it all the way through to the wonderful dedication ceremony this past summer. Um, Pete, it's a fantastic job. The tower looks great out there. Hopefully, we'll get some tenants next year. Um, you want to say anything about the project or the tower or future plans?
Yeah, I talked about it a bit earlier, but now that we're recording, the camera system that we had acquired for the tower didn't work as we had hoped to. And we haven't seen any evidence of nesting activities in the tower yet, but we have certainly hopes for future nesting seasons. And we have a good possibility of getting a functioning system. We have the power there now. We have the battery and solar panel. It's just a question of finding a good, reliable camera to work with them. We have funds, and I have talked to the park superintendent at Quiet Waters, and she seems enthusiastic about having us put a tower there. At the moment, I haven't pursued it because the construction material prices have been elevated because of COVID situation, and in fact, it's hard to get construction materials now. So that's sort of the plan, is when things become normalized in the way of cost of materials, to try to see about getting organized to have one constructed for Quiet Waters. Logistically, it's going to be more difficult because Kinder Farm Park is the only one that has a wood shop, and it's a really excellent wood shop. And the volunteers in the wood shop actually built the tower for us. I kibitz because they already had a team that was working together, and they have come up with a really improved design from what we had started with in the Kyle's book. It's a design that is very similar to the one that the Audubon Society in the Pittsburgh area used to build their 100 towers for their centennial in 2017. You know, that the Kyle's book that Chris just pointed out, it has a design that has a deficiency in that it calls for supporting the tower on a concrete pad, and the people that have construction experience feel that that's unsatisfactory in the sense it has no footings, which could be a hazard for something that's a 15-foot tall tower. The Kyles live in a valley, so they may not have difficulty with winds, but the one that's the design that the woodshop came up with uses the posts for the surrounding kiosk set into the ground to provide footings. So it's a really very substantial, safe structure. that we will try to use in the forthcoming towers, but it's going to be logistically a problem of, since we don't have wood shops in these other parks, of transporting pieces from Kinder Farm Park and assembling them on site.
Yeah, we'll have to be a little more creative than this last time and maybe do a little more assembly on site. But yeah, it, it it's great to have the friends at Kinder Farm working in their wood shop to help us do all this stuff. That was tremendous also.
Yeah, they're not interested in getting in the business of making towers, but they're at least the head of the wood shop has said that he is willing to be supportive in allowing us to use the wood shop and overseeing our activities. So if we do get around to doing it, I'll be looking for volunteers to help with the construction side of things.
Yeah, hopefully I think we'll be able to squeeze enough arms here to get some volunteers to help. I'd certainly like to help out and just be a part of doing that because I think that's just wonderful when you get that finished product. And hopefully we'll start to get a swift or a pair of swifts nesting in one of these towers. And yeah, hopefully we'll have two or maybe three within the next year or so.
Yeah, the Pittsburgh Audubon Society with their 100 towers, they're scattered around in the parks in the Pittsburgh area. And there are 3 locations where they've had fairly good success. So we're hoping to go up there and take a look and talk with the Audubon Society people to see what characteristics of the locations that we might be able to take advantage of in choosing a location like in Quiet Waters Park.
Mm, yeah. All right. Well, Pete, thanks so much for getting that project completed and dedicated, and we'll hopefully have some birds next year. What did that? Okay, let me make a mention about the board for 2021-22. We are still looking for some new faces to become part of the board. The positions, well, first I'll mention Kim. Wave your hand, Kim. Yay. Kim is our new secretary for the Bird Club, which I very much appreciate. We have openings for media coordinator, for hospitality chair, the program chair, which is also a second vice president. Pamela Kellett has continued as program chair, and we have programs lined up through the end of this year. So now might be a good time for somebody to come in, and you have a little more leeway time-wise to start planning for 2022. And we would love to have somebody come forward to be president. I will stay in this position until such time that we have somebody. I'm not going to just drop out of sight and leave you guys in a lurch. But yeah, if you know of anybody for any of these positions, you can contact me or just feel free to talk it up with that person. And let's try to get some new insights onto the board and can give us some new directions and maybe some new energy. That'd be great. The October meeting, let me put this in. There we go. Yeah. Okay. So I posted. Whoop, let me get rid of that B. Next month on October 20th, I posted information about the speaker, Larry Zoller. I'm guessing some of you know Larry. He's a past president of Anne Arundel Bird Club. taught in Anne Arundel County for 40 years. So he and his wife Diane are now in Raleigh, North Carolina. So he will be doing it by Zoom from North Carolina. I'm sure he would be very happy to have a lot of support from the people he used to work with and be in the club with here. Any other announcements that anybody has before we move on to the program part? Okay, this is where normally I would introduce the speaker. So I will introduce myself, and I will not read a bio. I've spoken to this group a couple of times already. If anybody really wants a bio from me, email me and I will gladly send it to you. But let me get things set up here. Okay, get that started. Whoops, not yet. Let me move this. I always have to move things around because I have too many screens. Okay, there's that. All right, so I will go ahead and start sharing my screen. And I would like to say that I am open to people asking questions along the way. If you have a question, you can just unmute yourself. I won't be able to be looking at the chat and doing this at the same time, but unmute yourself and just holler out and be glad to answer questions along the way. Oh, there it is way over there. All right. Okay. And if anybody's, oh, is that a hand raised?
Yeah.
Yes, Julie.
Hi there.
Hi.
I am, this is a question for Pete. And I would like to know how much the camera would cost to begin the chimney sweep or the chimney swift program.
Well, as I mentioned, we already have the solar panel and a battery for it. So the camera itself is probably on the order of 100 to 150, maybe even less than that. As I mentioned, I don't know what this new camera would be, what else we need to have it working properly. We may need a router as well, a little router to go along with it. But that's ballpark prices around that order.
Okay. Well, Pete, I would like to pledge right now $100
Oh, well,
towards the project. And I have your address and I will mail it to you. Okay.
okay. Well, the club.
Do I make it out to the Anne Arundel Bird Club?
Anne Arundel Bird Club, right?
You got it. Okay, thank you.
Thank you, Julia.
That's it. That's all I had.
Okay, great. All right, I'll get started with the presentation. So, as I hope everybody knows, my name is Chris Eberly. And tonight, I'm going to show you how ornithologists, who are bird scientists, are unlocking the mysteries of migration. I also want to show you some of the marvels of bird migration and introduce some of my personal migration champions to you. Within Maryland, there are currently 455 bird species have been recorded in the state. 206 of these are known to breed here. 143 are identified as species of greatest conservation need in the Maryland State Wildlife Action Plan. there are both resident and migrant species. And from a regulatory perspective, we have resident, short distance, long distance migrants. But from a regulatory perspective, specifically the Migratory Bird Treaty Act, all of these species are considered migratory birds. Here are some of the year-round resident birds. And we also have quite a few of these long distance or Nearctic neotropical migrant species, the warblers, thrushes, tanagers, our hummingbird. So these long distance migrants breed perhaps in Maryland here, but they spend the other 8 to 9 months in Latin America and the Caribbean. So are they really our birds, or are we just borrowing a few birds for a few months? So first I want to define some terminology and geographical terms. So what is migration? Simply stated, migration is a seasonal movement of birds that occurs to allow birds to access ample food resources. Short distance migrants generally migrate between or within the US and Canada. Long distance migrants, as I mentioned, also known as Nearctic neotropical migrants, um, go between breeding areas in the Nearctic region and non-breeding areas in the neotropics. So when I talk about, there's also a few species that undergo altitudinal migrations. In other words, they don't travel necessarily north-south, but they'll just go up and down in elevation depending on the time of year. So to give a little definition of these terms, basically speaking, the world is separated into these different geographical regions. The old world, or paleo, and the new world, or neo, equate to the eastern and western hemispheres. The Arctic region is generally considered to be north of the Tropic of Cancer, and it includes the Nearctic and the Palearctic regions and is sometimes referred to as the temperate zone. The whole Arctic region combines these two Arctic regions. Whole, H-O-L, means entire or whole. The tropical region is everything south of the Tropic of Cancer and includes the neotropical, afrotropical, or paleotropical, oriental, and the Australian regions. The holotropical region, as you might suspect, comprises all 4 of these tropical regions. The world's tropical regions generally lie between the tropics of Cancer and Capricorn, although regions south of Tropic of Capricorn are also considered part of the holotropics. Bird species around the world engage in some of these long distance migrations. And as you see from this map, many species will fly thousands of miles on their migration. Approximately 2/3 of all North American bird species migrate long distances each year. Biomes, we talk about sometimes. These biomes are groups of ecosystems, collections of ecosystems that have the same climate and dominant communities. When we look at migration patterns, it helps to understand what biomes birds are traveling between. The boreal forest, also called the taiga, is the largest forest biome in the world. Most of the long-distance migrants in eastern North America spend their non-breeding months from southern Mexico to the northern parts of South America and also in the Caribbean. For birds that overwinter in our area in the mid-Atlantic, this map shows where those species breed. The strongest link, which is the darker blue, are birds breeding in Alberta, Saskatchewan, and southern Manitoba. And yes, we consider this short distance migration. And these are probably some of the common species that we see in the wintertime that breed up in the boreal forest of Canada and Alaska and come down and visit us over the wintertime and give us a lot of enjoyment. For long distance migrants that breed in Maryland and the mid-Atlantic area, this map shows where these species spend their non-breeding period. The darker the red, the more of these priority species in that given geography. Mostly they spend their non-breeding period in the Caribbean, Central America, and Northeast South America, especially along the Andes. And in Mexico is primarily along this Gulf Caribbean slope. So you can see where they spread out with that. Now, for the most part, long distance migrants breeding in the western US do not overlap their winter ranges with birds from the eastern US. Sometimes they do, but for the most part, western breeding birds go in the western part, more like the Pacific slope of Mexico and the Pacific slopes of the Caribbean, occasionally into northern South America. One particularly interesting example that at least for me, of different migration strategies within one species is the yellow-rumped warbler. There are 4 forms of the yellow-rumped warbler. The myrtle form is the one we see in our area during migration and over the winter. It's also a common spring migrant passing through. The myrtles typically winter farther down in our area, but we can have some of those. Audubon's form is sort of the West Coast subspecies. It breeds Western U.S. up into Western Canada and winters from the Western United States, from the Western U.S. and Mexico, from California all the way down to into Oaxaca a little bit. Audubon's and myrtle warbler were recognized as separate species until 1973, when they were unfortunately lumped together due to a very narrow hybridization zone in Western Canada. And they remain that way as of now. The black-fronted form is a year-round resident of the Sierra Madre Mountains of Chihuahua and Durango, Mexico. And the Goldman's form is a year-round resident of southern Mexico and northern Guatemala. Interestingly, Goldman's form appears to exhibit some altitudinal migration. So within one species, that is a very wide spread of migration strategies. So hopefully a lot of you have become very familiar with eBird. eBird allows birders to enter their sightings well in the field via the app, or after the fact, you can go online and do that. The Cornell Lab of Ornithology has recently completed animated weekly abundance maps for most species that occur in North America. And here shows the general distribution map for yellow-rumped warbler. And so we put it into motion starting in January, and it runs through the end of the year. And you can see where the birds end up in the winter and where, and we'll run it again, where they are breeding. And you can kind of see, if you look closely, you can see some of these separate forms and where they might go. The eastern wintering birds, they sort of fill up in there. And the western birds just filling up right in this area. And this is a great tool. I really encourage you to get on eBird and explore some of these animations. They're really fun. The cerulean warbler is a really good example of a long-distance migrant that breeds in parts of Maryland. Their annual cycle diagram shows, and if you haven't seen one of these, this is an annual cycle diagram starting January and working around the year. Some of them go the other way, but for this illustration, I kind of went backwards. So the annual cycle diagram shows when and how long each period of the bird's year is spent. Most warblers, tanagers, orioles, and thrushes really only spend 2 to 3 months on the breeding ground, such as Maryland, each year. They will spend another month migrating south to the Latin American wintering grounds, where they then will spend the next 7 to 9 months. That's 2/3 to 3/4 of the year that they spend in Latin America. And finally, they will complete their annual cycle migrating back to the breeding grounds every spring. So now we're going to look at how we know where these birds go. So initially we had weather surveillance radar, WSR 88D, and that's weather surveillance radar, was implemented in 1988. The D is for Doppler. And nocturnal flight call monitoring was another. Satellite tracking is something else we use. Geolocators and different radio telemetry applications, stable isotopes, banding, various forms of wing tags. So let's take a little closer look at weather radar. So WSR 57 was the weather surveillance radar system that was implemented in 1957. And what you see here is one of the last images from the Miami's WSR 57 system before Hurricane Andrew destroyed it. And you can see, yeah, the center of the radar is probably right in around here where the radar system is, and Andrew kind of did a number on that. So in 1974, the next generation of weather surveillance radar was implemented. Really didn't have many significant changes, but it was much more reliable. Then in 1988, this weather surveillance radar 1988 with Doppler came out, also called Next Generation Radar or NEXRAD. So adding Doppler allowed the radar to detect not only the reflectivity and the density, but now it could also detect velocity and direction of what was being reflected. Ah, and it is happening. Good. This graphic doesn't always work. WSR 88D sites across the nation have now also been upgraded to use polarimetric radar, which adds a vertical polarization to the traditional horizontally polarized radio waves in order to more accurately discern what is reflecting the signal. So this so-called dual polarization allows the radar to distinguish between rain, hail, and snow, something the horizontally polarized radars previously could not accurately do. It can also do the same for birds too. So now not only can we determine how many birds are flying per cubic meter of airspace, but we can also distinguish the head from the tail, allowing, for instance, researchers to see how birds high in the air column are subtly compensating for things like crosswind and other forces. So dual polarization allowed a significant improvement in forecasting winter storms and severe thunderstorms, and it also ushered in an era that created what I like to call a new branch of bird study called radar ornithology. Well, I didn't call it that. It was penned by some well-deserving scientists. This is a composite radar showing all the NEXRAD or WSR88D sites across the country in one image. This is from November of 1988 at 7:16 in the evening Eastern time. And what you can see here, let me do the pointer. So what you can see here, this is a line of thunderstorms indicating a cold front that is coming through. All these other blobs here, these little circles, are birds lifting up into the atmosphere shortly after sunset. And of course, you know, in the fall, when you get one of these fronts that comes through, you get a prevailing north wind, which is very ideal for migration. And here's a shot showing the base reflectivity image from the Lake Charles, Louisiana radar site. What you can see is this real heavy dark cluster that looks like a real crazy storm. If we look at the base velocity, what we can see now is with the Doppler effect, we can see the green are images or reflections coming towards the radar. Red is going away from the radar. So what we're looking at here actually are flocks of trans-Gulf migrants making landfall along the Louisiana coast in spring migration. And pretty much they're setting down after that long journey. They're setting down in the first available habitat they can have after flying all night. This is another image from May of 2005 in 6:06 p.m. Central Time, showing a pretty strong line of thunderstorms um, heading down toward the coast. And then all of this mass here are flocks of migrants that are heading across the Gulf, and they're going to be plopping down as soon as they can. That yellow star there that's blinking a little bit is High Island, Texas. And if any of you saw the movie The Big Year, this is where all that fallout occurred that they ran to get to and flew to get to in a hurry. Although the actual fallouts probably don't really look like what they showed in the movie, but if you have never been to one, I was there one day after a fallout, and it is spectacular for sure. And here's another radar composite of spring migration in May of 2020, so just last year. So you can see lines of storms coming around, all this, and then these flocks, these little circles, again, are flocks of birds lifting off into the atmosphere to continue their migration northward. So when we look at finding, how many birds are we talking about through radar imaging? Um, This was really a technique that was developed by George Lowry and subsequently his student Sid Gotro, who I know Kyle on the call here knows very well, in addition to myself. Um, but they had the moon watching effect to kind of predict um, how many miles of birds per mile of front per hour, which ultimately then led to coming up with an estimate of the number of birds per cubic mile. And forward-looking infrared radar, or FLIR, has also been helpful in trying to help determine some of these values. So while we can see this relative migration traffic rate with the flocks of birds via radar, it really does not allow identification, individual identification down to the species level. So Birdcast, maybe some of you have taken a look at that, and right now would be a good time to get on to the Birdcast website and check out their migration predictions. But Birdcast essentially merged weather forecasting with bird migration data. So Birdcast basically is bird migration forecasting. And May of last year, what you can see is their prediction, and these higher yellows are where they predict the best migration. And you can see, and if you remember last year, there were some incredible migrations happening, spring migrations happening in May up through the Midwest. They also do it for the fall, and these predictions are online as we speak. So I encourage you to take a look at Birdcast. So many species of birds give a flight call during their nighttime migrations. And you can make your own nocturnal flight call recorder fairly easily using a bucket, a ceramic planter, a dinner plate, plastic wrap, and a microphone. At least before COVID, the material costs for this were between, say, $50 and $100, and you can find instructions pretty readily on the website. What these devices record are the acoustic signatures of these birds' call notes. So one of the neat things is it provides species-specific data, and it lets you detect otherwise secretive species just based on their ability or uh, their calling of these notes while they're migrating. Some of the disadvantages, um, it's not real good for detectability when there are species groups flying overhead. It's hard to interpret the numbers of birds, and it does potentially generate a lot of volume depending on how long you let it run and how many birds are flying over. But still, it's another tool, and it's a real fun one to start to learn nocturnal flight calls, which can be very different than just any calls given during the day that we normally hear. So Dr. Andy Farnsworth at the Cornell lab was instrumental in developing um, sort of the base level of flight calls for all the warblers. And this is what he calls the Rosetta Stone to the warblers with their nocturnal flight calls. Now, the use of stable isotopes has played a pretty important role too. So Dr. Pete Mara at then at the Smithsonian Migratory Bird Center, he's now at Georgetown University, had studied American redstarts across eastern North America. He looked at the isotopic signatures of birds. So feathers of most warblers are molted and regrown as soon as birds arrive on the breeding grounds. When they take the feather samples on the wintering grounds, they would have the isotopic signature of where the bird grew the feathers. So conversely, samples taken where birds arrive in the spring would have the signature of their wintering habitats. And what he discovered was something he calls migratory connectivity, the geographic linking of individuals or populations between different stages of the annual cycle, including between the breeding, migration, and wintering stages. And as you can see here, uh, American redstarts, you see the breeding range, the wintering range, but these are actual subpopulations, if you will, with migratory connectivity, that these birds in these different subgroups migrate between these two areas. And he identified those different areas for birds breeding here. So, birds that kind of breed around us will go down to the Caribbean. Birds up in the Northeast typically will go to Hispaniola. So from a conservation perspective, this has pretty huge implications. We can now study populations, vulnerability and dynamics of subpopulations, providing more geographically specific information, especially for those species that are going under population declines. So in the 1990s, ornithologists uncovered what was at the time the holy grail of migration tracking. No, it's not that holy grail. It was being able to track birds by satellite from the comfort of your home or your office. I think the first use of this was by Brian Woodbridge, shown here, releasing a red-shouldered hawk. But Woodbridge was then with the U.S. Forest Service. He was studying Swainson's hawks. For a decade, he had noticed the numbers of returning hawks sometimes were much lower than the number that departed the previous fall. And sometimes it was more adults coming back, then sometimes more juveniles. But in 1994, he was able to scrape enough funding together to buy 2 satellite backpack transmitters and outfitted 2 of these Swainson's hawks. One transmitter died almost immediately, but the second one worked beautifully and allowed him to track the birds to their previous unknown wintering area in the Pampas region of Argentina. And what he found there was a disaster that became a huge conservation success story. Down in the Pampas of Argentina, grasshoppers, they were eating grasshoppers. That's one of their preferred foods in the wintertime, and they go to these grasshopper outbreaks. These grasshoppers, however, were laced with a pesticide, monocrotophos, which was not sold in the US but was widely used by Argentine farmers to kill the grasshoppers during these outbreaks. However, long story short, once the rancheros knew what was happening, they became champions for their grasshopper plague stopper, because they really didn't understand the connection of what they were spraying on the grasshoppers and what that was doing to the Swainson's hawk. So now the tables have turned, and these ranchers down there are huge protectors of Swainson's hawks. Shortly after that, the Center for Conservation Research and Technology, later called Earthspan, outfitted another 30 Swainson's hawks. And range maps, which were educated guesses at the wintering range, suddenly became more accurate models of Swainson's hawk migration routes and overwintering areas. And you can see on this map, these are the exact locations that were revealed from satellite tracking to these exact spots. And at the time, yes, that was kind of the holy grail, that we now could track birds to their specific wintering locations and their migratory routes along the way. So Earthspan started outfitting peregrine falcons with satellite transmitters shortly after that. And this is showing the initial 18 months of satellite data they got. And in talking with them years ago, they said that those initial 18 months of satellite data provided far more information than their 25 previous years of data just with bird bands and recapturing the falcons. So for researchers working on these larger birds like peregrines and Swainson's hawks, they had indeed found their holy grail. The goal and hope of ornithologists was now to miniaturize satellite tracking technology to fit on passerines, small songbirds. Limiting factor then and today is power source. However, we have other options. Light level geolocators are a device that has a light sensor, an internal clock, battery, and a computer that stores a measurement of the amount of light that the sensor is exposed to. So by analyzing data from these light level geolocators, calculations on the sunrise and sunset can determine the bird's location to within about 250 miles. So a bird's location could be determined to be, for example, South Florida, but identifying a specific bird was not yet possible. And another drawback to this was that birds have to first be recaptured in order to access the data that is on one of these geolocators. So a few years back, Bird Studies Canada developed another new system. That was a system of automated radio telemetry called MODIS, MODIS being the Latin word for movement. MODIS towers can detect any species outfitted with a nanotag using a specific frequency range that passes by any MODIS tower anywhere, anytime. And recapturing the bird is not required for this technology. So here is a picture, and I think this is actually a little bit out of date, of the MODIS network in the Mid-Atlantic, Northeast U.S., and Southern Ontario, Canada. And when you add the range of these antenna, there you can kind of see, and this is a line that I think we have to thank Dave Brinker, Maryland DNR, for. This was for his Saw-Whet Owl project, that he put this line from northwest Pennsylvania down to southeast Pennsylvania. And he also has some across Maryland here. So basically, any birds coming from the northeast passing through here, if they have a MODIS tag on, they will be detected somewhere. And here's just to show some of the species that MODIS has been used on and is currently being used on. So not just thrushes, sparrows, warblers, and the saw-whet owls, but bats too. There's a lot of good studies and data. If you go to the MODIS website, you can actually see some of the studies and the tracks they found with bats. And they also have a nanotag that can be applied to monarch butterflies. And they are now working with this technology to track monarch butterflies. Hopefully, a bunch of you are participating in the third Breeding Bird Atlas for Maryland and the District of Columbia. A breeding bird atlas will show the distribution of breeding species during a 5-year window of data collection. And atlases become more valuable on the second and third iterations, which are usually about 20 years apart. And of course, Maryland has 2 atlases already completed, and we have now started the third atlas, which now we have just completed, I believe, the second data season. We have 3 more data collection seasons to go with that. And if you have not been involved yet, please get involved. This provides some really interesting data. So the type of data that an atlas will show, again, is the distribution and changes in distribution. So what we can see here, where the red triangles are atlas blocks that did not detect the Baltimore Oriole where it was detected on the first atlas. And the green circles are the opposite, where Baltimore Oriole was not detected on the first atlas, but was now detected on the second. So this gives you kind of a visual of where birds have dropped out and where they have appeared that they weren't before. And in addition, then we can look at trends from the breeding bird survey. And we can see that, yes, indeed, Baltimore Orioles are on the decline, long-term decline. And this is the abundant index, which is the relative number of birds detected per breeding bird survey route. And you can see it has dropped down a little bit more than we would like. So now I would like to introduce to you some of my personal migration champions. And let me tell you, this this changes frequently, and we will show you some of the things that have been changing recently. The categories that I want to just cover tonight are long distance, words for long distance, longest annual migration, longest nonstop flight, the deepest diver of a long distance migrant, smallest bird to cross the Gulf of Mexico, most energy efficient bird, the best contribution to science, the best coolness factor, and the most celestial migration. So let's get started. So let's start off with the winner for the smallest to cross the Gulf of Mexico. And some of you may know what this is. The ruby-throated hummingbird. So this bird weighs a little more than 1/10 of an ounce, which is about the same as a penny. It is about 3 3/4 inches in length, which is about 5 times the diameter of that penny. In spring migration, this bird will take off from the Yucatan Peninsula, fly 500 to 600 miles nonstop over the Gulf of Mexico. Pretty hardy stuff for such a little bird. And no, they do not hop on the back of larger birds to do this migration. Hope the Whimbrel gets an award for best contribution to science. So Hope the Whimbrel has made extraordinary flights over open ocean, encountered several major storms, and along with 24 other track birds revealed important details of Whimbrel migration previously unknown to science. A female Whimbrel like Hope will weigh just under a pound and is about 1.5 feet in length. The male is let's see, the male weighs about 12.5 ounces. The female is about 14 ounces. So researchers at the Center for Conservation Biology at the College of William and Mary tracked Hope back and forth 4 times between breeding grounds on the Mackenzie River Delta in the Northwest Territories of Canada and her wintering territory on Great Pond in St. Croix on the U.S. Virgin Islands. She recorded more than 50,000 miles, with each one-way journey being at least 7,000 miles. After her solar-powered transmitter failed, Hope was captured in November of 2012 in St. Croix. The transmitter was removed, and she was freed to continue her amazing journeys. To this point, this was the most successful tracking effort of a shorebird. And again, that is up to about 2012. If ever there was a bird that took the chill pill, it would have to be swallow-tailed kite. To watch this raptor soar slowly and effortlessly is just to have all your troubles melt away. Kites weigh about a pound, but will bulk up to 19 ounces before starting their fall migration. They are about 2 feet in length, but their total wingspan is about twice that. And like seabirds, kites are meant to soar for long periods of time. The Avian Research and Conservation Institute is probably the leading institute for research on swallowtail kites. This map shows the tracks of 8 kites that they tracked via satellite transmitters for one southbound migration. The average distance traveled by these kites was more than 5,600 miles. The next to last bird on this list, Slidell, with the red line, traveled a total of more than 45,000 miles over 4 different migration cycles between 2012 and 2016. So for its graceful soaring, beautiful lines, and ability to eat on the fly, I give the swallowtail kite the award for Best Coolness Factor of a Long-Distance Migrant. Our next award goes to the species with the longest non-stop flight without a rest. And the winner is the bar-tailed godwit. And based on new information, which I will talk about later, I put a little asterisk here because I now have to say that this applies to seabirds and shorebirds. During the breeding season, the bar-tailed godwit weighs in at about 9 ounces or so. However, it will double its mass to almost 19 ounces prior to undertaking the most extraordinary single flight of any bird. As most long-distance shorebirds, the godwit's wingspan is nearly twice its length. So you have to love the heart shape of this annual migration route. You know, this bird just loves to migrate. So the longest recorded nonstop flight without rest by this species, taking about 8 days to travel 7,250 miles from Alaska to New Zealand, averaging about 35 miles an hour. In March, it departs from New Zealand, makes a stopover of a few weeks in China, and then heads to Alaska once again. But last year, actually, this was now 2 years. No, yeah, this will still be last year. Last year, a new champion emerged. 1 year ago, September 16th, almost exactly 1 year ago, another bar-tailed godwit left Alaska and arrived in New Zealand 11 days later. It traveled more than 7,500 miles without stopping at speeds up to 55 miles an hour. It appears that easterly winds pushed this bird to the west, and it then corrected its course when it passed over New Caledonia and Papua New Guinea. During an annual cycle, the bar-tailed godwit covers about 18,000 miles. David Douglas with the U.S. Geological Survey in Alaska said, "This bar-tailed godwit can be considered the world's greatest athlete." Well, maybe, but I'm not sure I'm buying that just yet. So let's do a quick check-in at the Bat Cave. Alfred, what do you think? Oh, okay. He says perhaps, yes, perhaps. So we'll stay tuned for further developments. The sooty shearwater is one of the most common shorebirds in the seabirds in the world. They breed in enormous colonies in both the South Pacific and Atlantic Oceans on islands off Southeast Australia, New Zealand, and Tierra del Fuego in South America, where certain breeding congregations can exceed 2.5 million pairs. When not breeding, the sooty shearwater embarks on one of the largest mass migrations known. The sooty shearwater weighs about anywhere between 2 and 3 pounds. It is a typical seabird in many ways, including the fact that its wingspan is greater than twice its length. Seabirds soar for hours without flapping their wings, and they wander widely over the open ocean. The sooty stands out in one other aspect, though, from other seabirds. While it regularly dives to depths of 120 to 130 feet below the surface of the ocean to catch its prey, it can dive up to 225 feet. Therefore, I award the sooty shearwater deepest diver of a long distance migrant. But wait, there's more. As I mentioned before, after breeding, sooty shearwaters undertake one of the largest mass migrations in the animal world. For birds nesting off New Zealand or Australia, they will traverse the Pacific Ocean in a figure eight on a month-long foraging trip. It will leave its breeding grounds and it will travel east, sometimes all the way to the South American coast before turning north. After foraging in the North Pacific from China or Japan to Alaska and the west coast of the US, it will then return to the New Zealand breeding grounds. This round trip covers some 39,000 miles each year. There are 6 subspecies of red knot in the world, 2 of which are associated with the Americas. As you can see, they all breed in this whole Arctic region and migrate to tropical regions during the non-breeding season. The Roselari subspecies breeds in northwest Alaska and Siberia and winters on the Pacific coast. The Rufa subspecies breeds in the low latitudes of Arctic Canada and winters from the Gulf of Mexico to eastern South America. A red knot identified as B95, which is the leg band identifier, is the oldest known Rufa red knot in history. Prior to B95, the oldest known bird was 19 years, and as of his last sighting, B95 was 21. Rufa red knots are about a foot in length and weigh less than 5 ounces. B95 flies between the Arctic breeding grounds and its wintering home at the southern tip of South America, a round-trip journey of about 20,000 miles. On his northbound migration, he can fly non-stop for 5,000 miles over 6 days to go from the coast of Brazil to Delaware Bay. B95 has made this round-trip journey at least 24 times now with the latest data. So, B95 was born in Southampton Island in the Arctic in 93, banded in Tierra del Fuego in 95. Distance flown each year, about 20,000 miles. Distance flown in 24 years, which was the last known resighting of him, is about 480,000 miles. The distance to the moon and back It's about 480,000 miles. Hence, the bird has received his nickname of the moon bird. In recognition of this out of the world feat, I hereby bestow upon B95 the moon bird the award for most celestial migration. A new champion for the longest annual migration was declared after a study using light level geolocators finally unlocked the mystery of Arctic tern migration. The study tracked 11 Arctic terns fitted with geolocators for 1 year. These terns averaged about 44,000 miles round trip each year. In another study, one tern in particular traveled almost 60,000 miles in a year, equivalent to flying around the circumference of the Earth twice, plus 10,000 miles. Arctic terns can live up to 30 years. So in 30 years, that one tern would have flown over 1.8 million miles, enough to go to the moon and back almost 4 times. Because of that, I call this bird El pájaro de las cuatro lunas, the four moon bird. And now for our almost final award-winning migrant. The blackpoll warbler is a small wood warbler that breeds in the boreal forest of Canada and Alaska. It's about 5.5 inches in length, which is about the same as your standard iPhone models. It weighs just under a half ounce, which is about the same as 4 pennies. Blackpolls will fly up to 6,650 miles to get to a staging area of sorts on the New England coast every fall. If we wanted to help this bird, we could mail it from Yukon Charlie Preserve to the Rachel Carson National Wildlife Refuge, and it would only take one stamp. But wait, there's more. Blackpolls leave the New England coast when favorable northwest winds will carry them out over the Atlantic Ocean. As crazy as this sounds, it works. They continue until they hit the trade winds somewhere near Bermuda, which then redirect them toward the South American coast. When they finally make landfall in Venezuela, they may have flown 60 to 80 hours or longer nonstop and will have flapped their wings around 3 million times. A car with a gas burning engine with the same efficiency as a blackpoll warbler would get 720,000 miles per gallon. If this was a human runner, an avian physiologist studying blackpolls likened the bird's long distance flight to the medical equivalent of a 160-pound marathon runner averaging 4-minute miles for 70 miles and losing 40 pounds. The current marathon world record is 2 hours, 1 minute, 39 seconds, which is a pace of 4 minutes and 38 seconds per mile. A human equivalent of the blackpoll warbler could run a marathon in 1 hour and 45 minutes, 40 times in a row without stopping. For its feat of unimaginable endurance, I hereby award the blackpoll warbler the title of most energy efficient creature on the planet. However, I've been reading Scott Weidensaul's latest book on migration, A World on the Wing. And just as he did with Living on the Wind in 1989, the new research and incredible findings that he documents in A World on the Wing is just blowing me away. While birds don't need technology to do what they do, technology is allowing us to uncover migration feats that continue to get more and more impressive. Those of you old enough to remember the on-court exploits of John McEnroe will understand the title I am going to give this bird. You can't be serious. So we already know that swifts are amazing and spend their entire day on the wing. Alpine swifts are an unusually large species in the old world with a wingspan of about 22 inches. For a comparison, chimney swift wingspan is about 14 inches, and a common swift seen here is about 19 inches. In 2012, when ornithologists recovered data loggers placed on alpine swifts, their jaws dropped. Once the swifts began migrating south from Switzerland, crossing the Mediterranean and the Sahara into West Africa, they did not land for 200 days, more than 6 months of nonstop flying. Apologize, I had to plug in my device here. So they did not land for 200 days, which is more than 6 months. 6 months of nonstop flying. But as we've seen before, some birds just can't be and won't be outdone. Several years later, the results of a similar study on common swifts, like this one doing its best skimmer impression, would make even John McEnroe proud. Ornithologists discovered that some common swifts will spend fully 10 months on the wing in the West African wintering grounds. In other words, you can't be serious. Common swifts can obviously feed on the wing, and they're also practicing what we call unihemispheric sleep, where they can have half of their brain go to sleep at one time, and it happens fairly quickly, but it actually allows them to stay awake, so to speak, and flying. Weidensaul has this additional mind-blowing information in his book. What's more, they surpass even the masterfully gliding and soaring frigate birds in extreme energy conservation while aloft. A recent study of common swifts found they glide nearly 75% of the time, and they were so skilled at playing off changes in the airflow from rising thermals and other currents that their overall energy expenditure was not significantly different from zero. So, common swifts qualify for longest nonstop flight, most energy efficient, longest annual migration based on the hours they are in the air, and also, well, you can't be serious. So the common swift is now kind of my migration champion. So I want to close with a little sobering news, but end with a little good news on that. So hopefully many of you have seen this study that came out 2 years ago in Science that documented the loss of almost 3 billion birds since 1970. So in about 50 years, we have lost almost 30% of the breeding population of birds in North America. That comes up with Baltimore Orioles. We've lost about 2 out of every 5 of those. Long distance migrants in general have lost about 30%. Birds that nest in the eastern forests have dropped by about 17%. And alarmingly, we've lost about 6 in 10 wood thrush. Aerial insectivores have been hard hit with overall loss of about 32% and about 2 in 5 barn swallows that have been lost. And boreal forest birds are also taking a big hit. And in particular, the evening grosbeak, we have lost about 90% of the evening grosbeaks in North America in the last 50 years. But there are some simple actions. In fact, there are 7 simple actions that we all can do to help migratory birds and resident birds. We can make our windows safer. Windows kill up to 1 billion birds each year. And these are not just skyscrapers. These are small buildings and homes. And we can do citizen science or community science like Christmas bird counts, Project Feeder Watch, do eBird, do IBA monitoring, or do your breeding bird atlas work. And yes, we should work on keeping our cats indoors because cats do, in fact, kill at least 2 billion birds every year in North America. We can avoid and reduce plastic use because plastics are just not good for birds, for sea life of any kind, and for humans. Plant native. Native plants are better for birds. There is less to mow and water, and they use less, you don't need to have as much fertilizer and pesticide use for that. Shade grown coffee can help with these orioles, warblers, thrushes. 42 species of them spend their winters, at least in part, on coffee farms, shade grown coffee plantations in Latin America. And I'll do a shameless plug for, I think, the best coffee anywhere from Birds and Beans. If you go to the marylandbirds.org website and go to the coffee site, I have information how you can order coffee there. And yes, avoid pesticides. We're making some good progress on pesticides, but we can avoid using things like Roundup around our house. So those actions, all of us can do those. We can help keep these migratory birds migrating and keep them coming back so we can enjoy them for years to come. Just want to give acknowledgement to photographers of the pictures that I have been able to use. Here is a nice list of different websites with a lot of good information. And I will post this, maybe, I don't know. Well, I'll get this, it'll be posted in the on the YouTube channel, and I will add a page that will have this information. And here are some books that I recommend. And again, A World on the Wing is just phenomenal. That Scott Weinsold does a great job researching and then storytelling all the new research and the people that are doing these research projects to uncover these mysteries and miracles and marvels of migration. And with that, I have to show my honorary Mystery of the Missing Migrants by Charlie Harper, one of my my most favorite pieces of art. And I see we are at 8:25. That will conclude the show, the presentation. Let me stop sharing my screen. And at this point, let me get that back. Come on. So at this point, I guess we can officially end the meeting, but I am more than happy to stay on for as long as anybody wants to answer questions. And I'll leave the recording going for maybe 5 minutes or so. So with that, and I have not, if somebody, oh, there's nothing in the chat. Okay, so if you want to unmute yourself and ask a question, feel free, have at it. Thank you for your attention tonight. Kyle Rambo has his hand up. Kyle, show yourself.
All right, that gives me time to figure out how to unmute and turn on the video. So,
Cool. Hey, nice
nice
shirt.
job, nice job, Chris. Yeah, oh, thank you. Yeah, I mean, God, I was wearing it. One of my favorite pieces of art.
Yeah, cool.
Hey, yeah, not only, of course, did we both know Sid Gottro very well, but I inherited his first mobile avian radar unit.
Oh.
One came up from Colombia, so in fact, I had to buy it. I didn't.
Yeah.
I didn't get it bequeathed to me, but anyway.
Yeah.
Hey, in your readings, in Scott's book or any other readings, have you read about any recent research determining how birds learn where to go? Not how they get there, but how they learn. I mean, we're familiar with birds like waterfowl or cranes, the fly away home story where they're taught by adults or parents. But Sue and Alan and I were discussing this a week or two ago when we were looking at upland sandpipers there at Pax River, and they were late season juveniles. We talked about how the adults had already made the migration. The juveniles were going to join their parents on the wintering grounds, having never been there. How is that information communicated to those juveniles? And it almost seems like it has to be an inherited knowledge, which smells of Lamarckism and the inheritance of acquired characteristics, which I was always taught in biology, didn't happen. Any thoughts on that, or is it just another mystery we don't yet know about bird migration?
I think
some organic chemical means of communicating acquired knowledge.
Yeah, well, that's a little more nice sounding than I was going to say, but
Well, you won't have to read bedtime stories to your kids. You can just read the books and then just pass
Yeah.
that on genetically to them.
Yeah.
Right?
And that's the current thinking, is it somehow is genetically encoded. And it's not just sandpipers and shorebirds, but a lot of songbirds.
Yeah.
The adults leave first and then the juveniles go. And we've seen from some of these migration studies that around this area, a lot of the migrants right along the coast are juveniles. And the adults tend to, for the most part, spend a little more time further inland, which is, I guess, a learned attribute after they learn the basic route with that stuff. Monarch butterflies, it's the same thing. After how many broods going up, that last brood goes all the way from, Canada or the US down to Michoacan in Mexico. How does that happen? And another thing that along those lines is this whole thing of site fidelity too. So for instance, like Louisiana water thrush, we know, after they, when they start migrating after the breeding season, they'll go down to a certain area in Latin America. And then in the spring, they'll return back to around where they were born, or if it's the adult pair, they can actually go back to that same nest area. And then they will go back to the exact same spot in the wintering grounds. And they will actually go between two exact spots and defend those territories. So, how do they do all that navigation to get right down to that same patch, maybe within 100 square meters?
Yeah.
Is another one of those things. But it seems to be it's mostly somehow encoded into the DNA that they know how to do this. And man, if humans could just figure out how to get some of that DNA coding, we could be a lot more awesome.
Knowing what you did in an earlier life before birds, you got to be fascinated with the potential applications for storing data or data, chemically.
Yeah.
Through silicon or something. I don't know.
Yeah. Well, and that's, I gave the title of this, The Marvels and Mysteries. And it's just, to me, birds do what they do. Science is here to try to figure out what they're doing and why. And we'll never get there. And to me, that's part of the fun, is there's always going to be new stuff to learn. We're always going to be learning. And to me, that's the marvel, is that we can't figure it out. These birds have been doing it for long, long, long time, and they'll continue to do it. It's just fun.
I'll close my remarks with saying it is marvelous, but it's also humbling. I believe that humans don't invent anything. We only discover things and then do our best to mimic them. And anytime you think that, a helicopter is a fantastic flying machine, watch a hummingbird. We're not even close.
Yeah. Yeah. And how fast they can go forward, backward, up, down. And
we'll never get there.
In an instant. Poof. It's kind of like UFOs.
All right. Well, thank you. And again, nice job, Chris.
Yeah. Good to see you, Kyle.
Good to see you.
Alan. Yeah.
Yes. First, I want to say, Kyle, you drove me up next to these birds, these uplands, which was my life bird, right? We saw like 9 of them that day. You drove me up to them, and I was talking to them, but I recognized I don't know their language anymore. So thank you for that. And Chris, this presentation, I'm going to have to watch it 1,000,000 times to get my head around it. I mean, it was really, really, really like extraordinary, awesome. So thank you for it.
You're welcome. And the fun thing for me, I think I've given this 3 times now, and I always have to update it because I'm always finding something new that has been released. Some, new revelation, like this whole thing about common swifts can actually stay on the wing without coming down for 10 months. 10 months. And that whole thing about their energy efficiency, that they can do that and have like a net energy use of 0 is just, yeah, it's fun for me to prepare these. So maybe in a year I can do it again with a whole bunch of new information. All right, well, I'm gonna officially end the recording, and I will stick around if anybody wants to, but I want to thank everybody for being here, for being at the meeting, and for listening to the presentation. And please come back next month for Larry Zoller's talk. That promises to be a really fascinating one as well. So thanks and good night. And let me just stop the recording.